Oh, oh, this is a beautiful challenge. Very beautiful challenge. Look, like I'm always saying, when you got this question, it's always look alike. And you know, okay, which formula, which rule should I use? This is what I'm here for. To show you, okay, when I see the question like this is how I should approach. When I see in this form, or if I see the root, or whatever I see, so the tricks that I'm showing you, it's not about me solving and then you watch me like, oh, he can solve, and then how you learn from them. Huh? So now I'm going to show you, when you look at the questions, oh, this look like that. So I'm going to apply a certain rule. Now, let's get started. So, we have a little, I have to introduce myself. My name is Mntwana, African, original man. I'm a black man, original man. Okay? I'm a caveman. Huh? Let's get started. So, this is a question right here. They say, so, I can start with anyone. Okay, let me start with the first one. So the first one, when there's a root, what you need to do, separate, complete the square. I do believe you know how to complete the square, so I can just run away because complete the square, pretend good night. So I'm going to say the first one is going to be integral. We have 1, 1. Okay, this is going to be x plus 3 bracket, and this is going to be 5 minus 36, 5 minus 36 equals 29. 5 minus 36, okay, 5 minus 36, 31. So it's going to be minus 31, okay? But we have our root here. Yes, we have a root. I'll tell you why I'm doing this, right? So if somebody say 31 and 31 square root and square is the same thing, why? I'll tell you now why I'm doing it. So even though I know it's 31, because if it was 25, I then say 5 square, but it's not, this is not perfect square 31. 25, I will say 5 square. So 31, I'll say, put this under root, or let's use another color here. So I'm going to say, I'll take my 31, I'll put in a root, and then I'll square again for the reason. So I still have my minus. So then after that now, I'm going to show you the rule now. Why did I do what I do? Okay, why did I do what I do? If you have an integral in mathematics, and you have a 1 over, okay, you have a 1 over f of x, let's say minus or plus, or whatever. Like here is minus, minus. And then you have a a, and they have a root. Oh, my pen, I finished. Okay. And then dx, this is what you say 1 over, oh, you say ln, my point ln, and then you write your absolute 1 over a. A is this, whatever is in here. So for this case, what is a? Square root of 31. We just remove the square, it's going to be square root of 31, and then you say, okay, this must be bracket open. And then you write your absolute, write exactly, you write exactly, which is going to be f of x square minus a square, but you still have your root, and then you plus what? You plus your f of x with no square, and then you close your absolute because you open and close, then you close the absolute, close your bracket, then you plus c. So if you come here, we're going to use the same approach. The same approach, how we're going to say, well, this is going to be equal to ln, and then open the bracket 1 over a. What is a? A equal to square root of 31 with no square. And then I'm going to say, open my bracket, write exactly this one, but this is the same as that. So I can simply say square root of x squared plus 6x, and then plus 5. And then what we do, we say we plus only f of x plus 3 squared. So x plus 3 squared, x plus 3 what? Square. This one only stop here. And then you close your absolute, and then you plus your c. Close your absolute and close your bracket, plus c. Then we're done with that question. So this question here is done. Now we go to question number 2. Question number 2 is a little challenge, a little bit very challenge, you know. It's not hard, but it's challenge. So it's the same question, but now it doesn't have a root. So now it's going to be more challenging. Why am I saying it? You see now what I'm saying. It's challenge. It's not hard, it's challenge. So before you solve that, you know, because for now you don't know whether you're going to use, I'm going to use ln, or I'm going to use partial fraction, or I'm going to use completing the square, or how I'm going to do it, okay? Maybe I'm going to partial fraction and then integrate, and then I'm going to get ln. Or I can use completing the square, or I can use other methods. So what I'm going to do, I have to test. How I'm going to test? For you to test, always test, use the root of quadratic, which is say b squared equal to 4ac. If the root of quadratic is greater than 0, then yes, you can factorize. Then you have option whether you factorize or you can do completing the square. But only when there's no root and there's a 1 on top. Now let's go. But if it's less than 0, then you know this is the imaginary root. Imaginary root or non-real root. And if a non-real root means I'm not going to factorize, because if I factorize means it's going to give me a complex factorization, which I don't need it. You see what I'm saying? I don't need complex factorization because this is not complex integral. So I'm gonna say, okay, let me test b. What is b? B is 6 squared equal to 36 minus 4 times a equal to 1 times c equal to 5. And this is gonna be 36 minus 20. Oh, this is gonna be 16. Oh, so you can factorize if you want. Yes, it's acceptable. So either I can factorize if I, hold on, did I do right? 6 squared, yes, 6 squared minus 4 times 1 times c, 4 times 1 times, okay, 20, yeah. All right, so either I can factorize, or if I don't want to do that, I can use tan. Now let's see how we can do that. So we're gonna say right now, so I'm gonna say that one is gonna be integral. So this is gonna be 1 and this is gonna be x. Let's do 3 completing the square plus I don't know if it's plus or minus, so it's gonna be 5 minus 36. It's equal to negative 31. It's gonna be negative 31. So because the thing is, let's see, I think I can factorize. You know why I can factorize? Because I know my number is going to be 5 and 6. If I use this, it's going to be a very long method. So I'm not going to use this method because this one is going to have to take me to, I can do this, but I think it's going to be very long. So I'd rather just do by factorization because I know it's going to be 5 and 1, and then I can do partial fraction. So what I'm going to do, I'm not going to use that, what I want to do, complete the square. I'll skip that, I'll say integral. Okay, this is going to be 1, and this is going to be x plus 5, x plus 1. I do believe this is going to, yeah, dx. I can do that. So after that, then I'm going to separate. I'll take this one and break it down. So it's going to be 1, x plus 5, x plus 1, equal to a, x plus 5, plus b, x plus 1. Partial fraction. So what I'm going to do, I'm going to multiply by x plus 5 throughout. Multiply by x plus 5, x plus 1. So it's going to be x plus 5, x plus 1 for each one. X plus 5, x plus 1, and here x plus 5, x plus 1. Okay, look, this and this is going to cancel, so we left 1 equal to x plus 5 and x plus 5. So it's going to be a bracket x plus 1 bracket b, x plus 1 is going to be x plus 5. So what we're going to do here now, for me to get a, let's say I want to get a, means this b must be equal to 0. How am I going to make b equal to 0? To make b equal to 0 means this x must be equal to negative 5. So negative 5 plus 5 equal to 0. So 0 times b equal to 0. So everything is going to be equal to 0 when b equal to negative 5. When x equal to negative 5, my apology. So negative 5 plus 1, negative 4. Times b, negative 4a. Equal to positive 1. Divided by negative 4, negative 4. So a equal to 1 over 4 negative. Now we go for how are we going to get b. To get b, the same question. I'm going to say how I'm going to get a b means this x equal to, x must be equal to negative 1 for me to get b. Because if x equal to negative 1, means this is going to be negative 1 plus 1 equal to 0. 0 times a equal to 0. Negative 1 plus 5 plus 5 equal to 4. 4 times b, 4b. So this is going to be 4b equal to 1. Divided by 4, divided by 4. So our b equal to 1 over 4. So b equal to 1 over 4. So I can simply write here my a equal to negative 1 over 4. And my b equal to 1 over 4. So I got my a and my b. So what I will do, I'll replace here a and b. And then I'll come and integrate in terms of ln, which is going to be way easy. This question became easy. I thought maybe it's just going to be complex. It's easy actually. Okay, so I'm going to come and say, okay, I know my a and my b. So I'll say, my value of a, no. What is my a? Negative 1 over 4. So this will be negative 1 over 4. And b is going to be what? 1 over 4. 1 over 4. So now, remember there's an integral of this. Means if I integrate this, it's same as say integrate. Okay, let me do this. Okay. Integral of negative 1 over 4. But this is a constant, so I can go to the back. Say negative 1 over 4. What? X plus 5. Because this was a here. A. And then dx. Okay. Plus. 1 over 4 for b, because this will be 1 over 4, integral, and they say 1x plus 1 dx. Then we can finish, because this is going to be, I can take 1 over 4 out. Let's take 1 over 4 out. If I take 1 over 4 out, and then I'll sack this one, it's going to be 1 integral x plus 1, which is going to be ln absolute x plus 1, and then minus, because I'll start with this one, I take 1 over 4, I'll start with the positive. Means this, and if 1 over 4 went out, and then when I integrate this is going to take, okay, minus, because this minus 1 over 4 went out, minus, okay, this could be ln integral of x plus 5, and then ln x plus 5. plus C. So then we're done. You see what I'm saying? It was actually way easy. I never expected like it's just gonna be easy like that. Okay. So we're done with B, now we go for C. So this is gonna be a challenge. Okay, sorry, just a second. I just want to clean my whiteboard. I thought it was going to be more challenging, but it was easy because sometimes, you know, it can be challenging a little bit, you know. Sorry, trying to put some cleaner, you know, whiteboard cleaner, because sometimes my board is very dirty. You guys cannot see it, but it's very dirty, you know, because you're in the camera, you have behind the camera, so you don't see like that, but hey, it's dirty. So you go to 3 and 4, and then the last one is very easy. Okay, so it's me. 3 and 4, and then we'll finish, right? Finish very soon. Okay, cool. Let's not play now. Let's go to a business. Maybe I can do 5 and 6 and then go 3 and 4. No, let's go with the order, so we can get done with this. Okay. This is way easy because this one, I'll complete the square and they say, okay, this one is integral. Okay. 1 over, so this will be x, completing the square, x plus 1 square, because, okay, 2 divided by 2 equal to 1, 1 square equal to 1, and then here is going to be 10, 10 minus that 1, which is going to be equal to 9. But what is 9? 9 meaning plus 3 square. So this is, you can do tan, trig tan substitution, because in a trig tan, we know, if somebody give you 1, and they give f of x plus a squared dx, this may say 1 over a, and they say tan inverse, or you can say arctan, or you say arctan or tan inverse is the same thing. F of x, and they divide by a, and they plus c. So same here, because f of x, square, square, plus a is 3 square. So it's going to be 1 over a. What is a? A is that number, which is 3, no square. And then arctan. Arctan means tan inverse. We say tan inverse of x plus 1. In this one, no square. Then we divide by this number, which is here, which is 3, with no square. Plus c. So we're done with question number 3, we go to question number 4. So question number 4, I think I show you, I explained that. So first and foremost, we must put in it, completing the square. Completing the square means it's going to be like 1 over, and this is going to be x plus 1 square plus 3 square. But I remember have a root. So this one here, okay, I'm going to spell something. If you have an integral, 1 and then you have a root f of x plus a square. This same is say dx here, sorry, because it's x, everything with respect to x. So this is going to be, say, ln 1 over a is this number, and then write your absolute, write exactly your function. And then you plus your a, and then you plus only this function with no square. And then you open the absolute, right? Make sure you close the absolute, and then you plus c. But remember, you open brackets, so you must close the bracket. That's all. So we're going to do the same thing for that one. So that one is going to become, okay, ln, because you can see in this format. This is in this format. Ln 1 over a. What is a? A equal to 3. Okay, absolute, absolute. Okay, this, which is this. But this, remember this. So I can rather write this one or this one. Either of the two, but I write this one. This is this, remember, we just complete the square. So I can say x squared plus 2x plus 10. And then we say plus plus f of x. What is f of x? F of x means these alone. With no a. What is f of x? With no square, remember, right? So it's x plus 1. And then remember, absolutely did open. You must close your absolute and then close the bracket, close it there, and then plus 6. So we're done with question number 3. Number 4, we'll go to question number 5, and then 6 we finish, we go. Easy. Easy. Easy, baby. Baby, 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 baby. Easy. But I'm tracing. I love math. Okay, look. This is a tricky double angle, but they don't tell you it's double angle. If you have an integral, there's a square something. integral square, whatever, it does not matter here as long as square. This is how you do, right? Remember, tricky double angle. Tricky double angle is like this. Let me write all them so you can understand. Cos double angle equal to, okay, let's put x because we use x now, equal to cos square angle minus sine square angle. Me, I know by head, but I want to show you so you can know sometime, because sometimes you forget, they don't give you formula all the time, so you have to derivate and know how it comes about. Now look, if let's say, okay, cos double angle. Let's say I don't want to have a cos. What is cos? Cos means 1 minus sine square. So this I can replace 1 minus sine square. So I can say this equal to 1 minus sine square minus what? 2 sine square. So cos double angle also equal to this one. Or use the same one, right? Let's say I wanna replace this. So this is 1 minus cos square x. So cos square x minus plus, because it's gonna be plus 2. So it's gonna be cos double 2x equal to, this is gonna be plus, right? It's gonna be 2 cos minus 1. Use the same question. So so cos double angle either can be equal to this one or this one or this one. So depending on the question. So if you can look this one, have a cos square x, I'd rather use this. So what is cos square x? Cos square x equal to cos 2x plus 1 over 2. Oh, okay. So integral cos square x, what is cos square x? Because this one, the 1, means cos 2x plus 1 divided by this 2. So it's going to be cos 2x plus 1 over 2. But this 2 can go to the back, dx. 2 go to the back, 1 over 2 integral, put bracket, and then you can say 2 go to the back, so it's like cos 2x plus 1. Okay, now you can integrate separately. So we still have a half outside. Okay, when you integrate this, it's going to be 1 over 2. 1 over 2. Okay, because look, if somebody give you integral cos a function, this same as say dx cos a function dx equal to 1 over derivative of function, means derivate this function, and then it's going to be sine of f of x. Let's see. Sorry, my handwriting. I was trying to be like a doctor right there. So now here's going to be, okay, a half. When you integrate, cos means you have to derivate this 1 over, and then you write the answer, which is going to be 2, and then you derivate cos 2x, it's going to be sine 2x sine 2x. That one was dirty. Sine 2x over 2. Okay, now when you integrate 1 dx equal to x. Okay, and then you plus constant because you don't have no limit. So this is going to be a half, this is going to be sine 2x over 4 because 2 and 2 equal to 4. And then this and this is going to be plus a half x or 0.5x if you want to say 0.5. Plus c because you don't have no limit. So we come for the next one. The next one, the same tactics, right? They want sine 3x, means I'd rather use this one. Sine, so square, but this is 3, means this must be 3 here. This must be 3. So if this 3 means this must be 6 because it's twice of it. So now if I want to replace sine, look, if I replace this, how am I going to replace, look, means this. If I replace sine 3x, look, it's going to be, this sine, go to this side, it's going to be 2 sine square 3x equal to, because it became positive. And this is going to be 1 minus cos 6x divided by 2 divided by 2, and this cancel. So this and this cancel. So sine square 3x equal to 1 minus cos 6x over 2. So I can replace it. Let's say integral. Okay, this one's going to be, I can take 1 over 2 out. 1 over 2, and then I can put bracket, and then I can say 1 minus cos 6x dx. Okay, and then this one now we can finalize. You can say, well, I have to just leave it first. Integral of 1 dx equal to x minus. When you integrate cos 6x, differentiate this. So 1 over the differential of 6x equal to 6, and then when you integrate cos 6 equal to sine 6x and plus c. But multiply that out, it's going to be a half x. Let me be note now. Let me not put fraction, 0.5x. And this is a half x. Half x minus, this is going to be 1 over 12 sine 6x plus c. C is a constant because we don't have no limit. Look here. This was easy. That's what I say. Now I understand why I love it. Oh my God. Nah, it's easy. Can you see how we did it? Thanks a lot for your time. Follow me on Instagram, Mntwana_Wabantu. Mntwana_Wabantu on Instagram, excuse me. On Facebook, Mntwana Wabantu. Follow me on social media. Like the video. Leave the comments below, man. I'm a original black man. Kev man. Peace, man. I'll see you soon.